This is the first time we've tried this kind of question in this series of lessons. Have a go in your own time. I'll walk through an answer in a moment. So the actual answer is x equals minus 2 or x equals minus 3. Let's look at y. Okay, so here's the thing. The thing is, on the face of it, you can't solve it because it's got an x squared and an x. And remember that these are two different things. So how do we do it then? The answer is we use a trick. I'm trying to think off the top of my head. I think this is the only trick that I cover in any of these lessons. It's one of the only tricks I've ever learnt for maths. There's very few actual tricks that you need in maths, and this is one of them. You have to realise that you need to factorise it. So I'm just going to factorise it. If you're not sure that that's how you factorise it, pause the video and have a go at, say, multiplying it out. You know, remember doing this. Something like that. Make yourself comfortable with the idea that's what it is, factorised. Anyway, there you go. I've now factorised it. And then, here's the thing. We go, wait, we've got two things multiplied together that make 0, which means one of them has to be 0. So I'm just going to drop a line down. And I'm going to say, well, x plus 3 equals 0. Or x plus 2 equals 0. So our minus 3 here, because I've got a little equation to solve, so that means x equals minus 3. Or I'll minus 2 from both sides here, which gives me x equals minus 2. That's how that works. Takes long. You should pause the video if you need to, look at it. But I mean, obviously, go and find other examples. We'll be doing this sort of question again and again. Let's do the next question. Pause the video, have a go in your own time. The answer is not possible, because there's 4 variables and there's only one equation. Have a go at this one in your own time. The answer is x equals 81. And I'm going to do that by inspection, because to me that seems kind of obvious. Well, the square of 81 is 9. Okay, how could we do that a bit more mathematically, which in this case I don't think is necessary because it's sufficiently obvious. We could, well, let me write it out again. We need to do something to both sides. What if we square both sides? So what I'm going to do is I'll use a circle. I always use a circle to indicate what I'm going to do to both sides. I'm going to square both sides. So I'll just do a little box, put a little squared at the top. So I've just got the square of x squared equals 9 squared. Oh, wait, the square of x squared is just x because it kind of cancels out. And then 9 squared is 81, so there you go, we've done that. A bit more mathsy. Next question. Have a go in your own time. So, here's the thing. What is it? Well, I think this one's a bit trickier. You can still kind of do it by inspection. Let's try and do it by inspection, because it's good practice. Well, I've got 3/10 and 1/10, so what would need to go here? This would need to be 2/10, wouldn't it? So that means that we know that 1 over m has to be equal to 2/10. Let's make it look the same. Remember, as in maths, this is only one way of doing it. So I'm going to multiply the top and the bottom by 2. So that means that 2 over 2m equals 2 over 10. Now I can tell that by inspection m equals 5. There you go. We just solved it. Oh, we can just fit all that on the screen, can't we? So 1/5 plus 1/10 is 3/10. Pause the video if you need to and just kind of confirm that's correct. And you might have done that other ways. You might have kind of multiplied through, done some complicated algebra. But basically, again, I just wanted to model the important techniques that look the same and by inspection. Okay, pause the video, have a go in your own time. And the answer to this one is not possible. But wait, there's two equations and two unknowns. Here's the thing. Let's take one equation and put it into the other one. A minus B, I know that A is the same as B, so I could just write A minus A equals 10. Well, that's not possible, is it? Because that's A minus A is 0. 0 isn't equal to 10. So the two equations contradict, therefore we can't solve them. By the way, you might say no solutions. You might have said that instead, or you might have said no real solutions, blah, blah, blah. I'm quite happy in the context of the learning we're doing at the moment if you said not possible. It was kind of what I was expecting, but arguably some of the other answers are in fact more complete and better. Have a go at this in your own time. Make look same. Got to try and make it look the same. I can see brackets on the left side. I can't see brackets on the right hand side, so I'm going to get rid of the brackets. So 2x minus 6 plus 4 equals 2x plus q. I think this is going to work out, isn't it? Minus 6 plus 4 makes minus 2. Oh, look. So q equals minus 2. If you're not convinced yet, let's just compare as we do. There's an equal sign, so we can compare to each side of the equal sign. There's a 2 each side, there's a x each side, there's a minus. Well, there isn't a minus side each sign, but there's a minus 2 and there's a plus x, which means that q must be minus 2. Ta-da! Insert question here. We don't have an actual question for this one. I've just got a bunch of things, and then there's going to be a couple of spaces. Just kind of improvise. Find something to do. I'll tell you when I've finished writing. Have a go in your own time. There's no title. There's two boxes. In case you're not quite sure what I mean, there's two boxes. You see there's two boxes there. So you need to fill in those two boxes. Wonder what goes inside. Right. I'm going to have a go at answering this. Well, this is weird, but there's like an F, and then there's like a number inside the F. That's supposed to be a 0, by the way. If you thought it was another number, maybe go away and fix your answer. Apologies. Now, so there's like an F, and then there's a number in brackets. Then on the other side, sometimes there's an answer, and sometimes it's asking us to put an answer in. Well, so okay, let's just play around with this. How do we get from 5 to 8? That's just plus 3. 23, that's plus, oh, that's plus 3 as well. Oh, okay, so I guess 0 plus 3 is 3. What's k plus 3? Well, it's k plus 3. There you go. That's how that works. Now we can fill in a title. We could call it functions. There you go. There's a kind of title for that question. Let's do the next question. I've given you 3 to do here. So have a go in your own time. And if you've just rejoined me and you didn't know what to do, how about drawing a table? So drawing a table can be a very good way of checking your answer. Meanwhile, I'm about to draw the answers on to show you what they are. And they are. There we go. That's the answers. I'll just cover it up in purple just to reinforce the purple line is the answer and the green line are the axes. And remember, if you weren't sure, let's for example do the y equals 3. We draw a table with x and y. So, oh, what if x is 0? Y is 3. Okay, well, I can plot that point. What if x is 5? Oh, well, y is 3, because it's always 3. Okay, well, that works. What if x is minus 2? Oh, well, it's 3. Okay. Oh, yeah, yeah. You can do similar things for the others. Let's do a factorized question next. Have a go at this in your own time. And the answer is x to the 4, x plus 1. Right. Jump to the next question if you're happy. Otherwise, let's look at y. The first one is x times x times x times x times x. Plus, the second one is x times x times x times x. By the way, little side note, notice that my x's are curly. And my, oops. And my times signs are straight. I do that on purpose. I always do curly x's so I can tell them apart from times signs. Anyway, where was I? Right. We can take an x outside the bracket. We can take another x outside the bracket. We can take another x outside the bracket. We can take another x outside the bracket. There's nothing left on the right, so obviously that has to be plus 1. There's still an x left there. What's x times x times x times x? That's just x to the 4. Not necessarily that's not necessarily the way to actually do it, but that's a really nice way for a teacher, for example, just to go through it nice and gently, just to help a student kind of see what's going on. Let's look at the next question. Let's do a calculate question. There's 2 here. So just 2. So let me write the first one and the second one's on its way. Have a go in your own time and then I'll write out the answers. If you got that, great. See you at the next question. Jump ahead. Otherwise, remember the first one. Actually, I bet a lot of people got the second one wrong. Look at this. You've got a 3. That is plus 3. So imagine a number line. We're now at plus 3. That is plus 1. So we've now moved to 4. That is minus 3. So we've now jumped back to 1. And then what happens with the last one? Oh, that's plus 1. So we've now ended up at 2. So the mistake some people make is they try to cancel. They go, oh, there's a minus sign, so I guess I just take away that. No, 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 no. The minus sign is only attached to the 3. That last one is actually a plus 1. So that's why the answer is 2. And this one up here, well, that's, remember, squared means multiply by itself, so that's a third times a third. And the way you multiply fractions, 1 times 1 is 1, 3 times 3 is 9. There we go. By the way, if you made the mistake of putting a 2 at the top, I would say you might think that's not a serious mistake. I think that's a very serious mistake in the sense that you need to try and build your awareness. There's something going on in your head there. Your brain isn't working through the maths logically enough. You need to be more logical. You need to see that and think, oh, that means whenever you see a power, that's like timesing. It's a timesing thing. Think about timesing. What is 1 times 1? 1 times 1 is 1. The answer is 1 over 9. Okay. I think I've gone on about that enough. Let's do another calculate. Oh, yeah. This is very similar to my favourite question that we talked about before. This time I'll try and write it out correctly. Have a go at this in your own time. See you back here in a minute. And the answers are... There we go. I feel like you can probably work that yourself. Remember that anything divided by anything, if it's the same, is just 1. 10 divided by 10 is 1. Half divided by half is 1, blah, blah, blah. Next question. We've got some more calculates. Oh, this is quite interesting. This is just looking at some sort of issues that can crop up in relation to, well, I'm not going to say it, but I think there's a good chance that you're going to be, oh, this is a Duncan's testing us on blah, blah, blah. Here, there you go, I've finished. Have a go in your own time. I'm, of course, testing you on BidMaths. I'll just write out the answers first, which is always dangerous because it means I'm going fast. I shouldn't really be doing it this quickly, but I'm trying to just get it done so that you can see. Yeah, that's 5. That's right. There we go. Right. Now let's do it at a sensible speed. I just took a bit of a risk there. So that is simply 5 times minus 1. Oh, because remember that there's an invisible times sign between the 5 and the bracket. Because there was no symbol there, was a symbol missing. So that's minus 5. This is obviously 4, that's fine. Well, what's 1 squared? Is the squared acting on the 1? Yes. Is it acting on the minus sign? No, it's not, because it's only acting on the thing directly to its left. So that's 5 minus 1 times 1, which is 5 minus 1, which is 4. There we go. This one's interesting. There's an invisible times sign there, so that's 5 times minus 1 times minus 1, effectively. Oh, and minus 1 times minus 1 is 1, so that's just 5 times 1, which is 5. This one, there's a plus sign. The squared is acting on the bracket, so that's going to be 5 plus, then it's minus 1 times minus 1. Let me just put brackets round. So minus 1 times minus 1 is plus 1, so that's 5 times 1, which is 5. Up to, whoa. No, whoa. Which is 5 plus 1, because there was a plus sign there, which makes 6. There we go. Let's look at the next question, which is in fact the penultimate question. I was speaking slowly because I was kind of looking across at my notes and I was getting lost. Right, so this is expand and simplify. Remember, simplify means tidy up. So it's basically saying expand, whatever that means, and then please tidy up your answer. That's in exam speak. Have a go in your own time, then I'm going to do it. X times x is x squared. X times 6 is 6x. 1 times x is x. 1 times 6 is 6. Now let's add them all together. There's 1x squared. There's 6 plus 1 makes 7x's. And there's just on its own, as a number, there's 6. So that's the answer. There we go. Why is that useful? I think that's useful because that's helping us get our head around doing the opposite, which remember we need to do when we're solving those equations. Remember when we solved the equation way earlier, the equation that looked like this. So we had to solve that, and we said, oh, why don't we factorize it? And then we've got 2 things multiplied together, which we can then solve, because 2 things multiplied together to make 0, one of them has to be 0. Do you remember that? Let me just say that one more time. Here, we're looking at expanding, which is useful on it kind of on its own, but particularly because we can use it later for factorizing, which is useful in this situation where you're trying to solve an equation where it's like an x squared and an x. By factorizing, you turn it into brackets, and then that means you can solve it. And remember, this is a trick. It's a trick. Everything else that we've done basically makes logical sense. This one thing here, it's like a lot of students go, but when I'm solving an equation, why do I know that I have to put it into brackets? Well, the answer is because it's just what you do. It's a trick. Does that mean all of maths is a trick? No, all of maths is not a trick. Just that one thing in maths is a trick. But I mean, there are some other tricks as well, but basically that particular thing is a trick. Most other stuff isn't tricks, and so it's weird, it's unusual. Okay, have a go at this question in your own time. If you're not sure what to do, remember the skill which is called same to both sides, because that's what we're going to be using here. I would like to get rid of the fraction first. For me, that is the really important thing to do. Let's get rid of this fraction, because that's horrible. 10 plus x equals 6.2. Because it's multiplying, so you do it to each thing. Now, I'm going to minus 10 from both sides. And because I'm minusing, I do it once to each side. So just to spell that out, I've got 10 plus x minus 10 equals 6.2 minus 10. They cancel, so I end up with x equals whatever 6.2 minus 10 is, which is minus 3.8. That's the answer. Good work. See you in the next video.